Well, today I want to start by introducing the concept of the air quality index. The air quality index is clearly just a ratio of the measured value of one of the criteria air pollutants divided by the national ambient air quality standard for that species times 100. And you can calculate an air quality index for each individual criteria air pollutant, and then the air quality index that's actually reported is the maximum of any one of those air quality indices for the individual criteria air pollutants. So what I have here are the 1 hour, the 24-hour, the 8-hour standards for most of these, which is what we're looking at on a daily basis. There are also national ambient air quality standards for annual exposures that are looking at chronic exposure as opposed to acute exposure that we have here. So in the interpretation of the air quality index, if the air quality index is greater than 100, then it means that the concentration, the measured concentration, is greater than the standard, which means it'll be unhealthy. Between 100 and 101 and 150, it's unhealthy for sensitive groups. Between 150 and 200, it's generally unhealthy, and beyond that, it's very unhealthy. And to have good air quality, we generally want the air quality index to be less than 50. So here's an example using 4 criteria air pollutants. We have PM 2.5, PM 10. The measured concentrations of these were 50 and 120 micrograms per cubic meter respectively. The national ambient air quality standards for each of those was 35 and 150. And so the air quality index is just calculated as the concentration divided by the national ambient air quality standard times 100. So for PM 2.5, you'll see that the air quality index is 142. For PM10, it's 80. For ozone and carbon monoxide, the air quality index is even less. And for ozone, I just want to point out that it can be reported in parts per billion or parts per million, depending upon the instrumentation that's being used and depending upon the agency at which you're accessing the data. I typically, in atmospheric chemistry, deal with ozone in parts per billion, but the Division of Air Quality here in Salt Lake City uses the ozone concentration in parts per million. So the National Ambient Air Quality Standard of 70 parts per billion is equivalent to a concentration of 0.07 ppm, parts per million. So we've already kind of talked about the health impacts of particulate matter, but I just want to remind you that the acute impacts, the things that happen quickly, are your respiratory symptoms, your decreased lung function, and your aggravated asthma. And the chronic exposure can lead to chronic bronchitis. It can lead to irregular heartbeat, heart attacks, cardiovascular disease, and premature death. And the sources of that particulate matter, the primary sources, the ones that are emitted directly to the atmosphere, would be incomplete combustion. Anytime that you have incomplete combustion, you end up with some hydrocarbons that come out of the system, and in this case that would be soot. We can have windblown soil, and windblown soil can be either from natural sources or from disturbed surfaces. You have sea salt, you have volcanoes, you have plant spores and pollen, and anybody who has allergic reaction to those will definitely know that they're there. And then we have our secondary sources of particulate matter. Anything that emits sulfur dioxide or nitrogen oxides or volatile organic compounds, those materials will eventually end up as particles through the process of gas to particle conversion. And then we also have the hazardous air pollutants in addition to the criteria air pollutants. And these hazardous air pollutants can cause cancer or can have serious effects, birth defects and that sort of thing. There are currently more than 600 hazardous air pollutants that are tracked by the EPA. And some examples of those, the things you might be familiar with, are asbestos, benzene, toluene, vinyl chloride, mercury, cadmium, arsenic, etc. So let's take a look at the National Ambient Air Quality Standard for carbon monoxide. So the 8-hour averaging time is 9 parts per million, and the 1 hour averaging time is 35 parts per million. And these are the primary standards designed to protect human health. The secondary standards are to protect infrastructure or plants and animals. And there are no areas in the country that are currently in non-attainment for carbon monoxide, and there haven't been any violations in Utah since 1993, although we still have 3 maintenance areas that are under continuous watch for carbon monoxide. So let's take a look at the trends of air quality in the United States on the left and in the Salt Lake City, Wasatch Front urban area on the right. So on the left, the white line is the median of all of the EPA monitoring stations starting from 1980 all the way up through 2009. And the blue shaded area represents the range of all of the sites across the United States. So back in 1980, 50% of all of the sites in the United States had carbon monoxide concentrations that were greater than the national standard. By the early 1990s, none of the sites in the US were violating the national standard, and that trend has continued all the way down through 2009, 2010, and it's basically started to level off afterwards, with the data not shown. The same thing was true here in Salt Lake City. Looking at data starting in 1990, we were already below the national standard and have gone significantly below since. So we do have maintenance areas. So the way the EPA works is if you're in non-attainment, then you have to generate a state implementation plan to show how you'll get back into compliance. Once you get back into compliance, for a number of years, then you're taken out of non-attainment status and put in maintenance status, where things are continuing to be monitored, and you'll be in maintenance status for more than a decade until they are sure that your changes that you've made have made permanent improvements in the air quality. So why are the carbon monoxide concentrations decreasing? Well, the primary reason is technological advancement, specifically the replacement of the mechanical carburetor with the computer-controlled fuel injection in gasoline-powered vehicles. So the old carburetor systems that were mechanical needed to be tuned up regularly, otherwise they would have an incorrect mixture of fuel and air. And when you have that case, you have incomplete combustion, and carbon monoxide is one of the things that results. For the computer-controlled fuel injection systems, they generally do a pretty good job of getting the fuel-air mixture correct, but the way that they fail is that the oxygen sensor will sometimes fail or will become contaminated, and then the computer won't know exactly how much oxygen is there, and it can run fuel-rich. So the other things that are causing carbon monoxide to decrease is the increased fuel economy. You know, back in the 1980s, the average car got about 15 miles to the gallon, and it's significantly greater than that now, so there's less burning of fossil fuels. And then in Utah, we also have the Motor Vehicle Emission Inspection and Maintenance Program. It was initiated in 1984, and in Salt Lake City anyway, and it's designed to measure the emissions from your cars every year or two, depending upon the age of your vehicle, to ensure that the system is running correctly and it's not spewing out high concentrations of carbon monoxide or nitrogen oxides. If we look at the National Ambient Air Quality Standards for lead, lead is a particle in the atmosphere, and they don't have daily measurements of lead, so they use a rolling 3-month average. And you'll see that the primary standards have changed. Initially, it was 1.5 microgram per cubic meter from 1978 to 2008, and then it switched to 0.15 micrograms per cubic meter starting in 2008. And that's based upon increasing our understanding of the health impacts of lead. And the scientific literature showed that the original primary standard was insufficient to protect human health. And there are currently 15 counties in the United States that are designated as non-attainment for atmospheric lead. All of those areas that are in non-attainment are basically cities, and some of these are also areas where we have industrial activity that can lead to lead in the air as well. So let's take a look at the lead trends. Back in the early 1980s, about 50% of all of the sites in the UPA network were greater than the standard of 1.5. And then throughout the 1980s and into the early 1990s, the lead concentrations in the atmosphere decreased substantially and continued to decrease over time, and until they got well below, below the new National Ambient Air Quality Standard. And here in Utah, the concentrations have been slightly below the revised standard of 0.15 since they started taking measurements in 1992. So that represents a 93% decrease over the 30-year period from 1980 to 2009. So why did the lead concentrations decrease during that time period? Well, lead was in the gasoline that we used in our cars. It was used as an additive to prevent engine knocking. And it was phased out starting in 1973 because it was incompatible with the catalytic converters, the pollution control devices that were put on cars. Catalytic converters are designed to scrub out nitrogen oxides from the emissions. But if you have lead in the fuel, not only does the catalytic converter not work, but you still have the lead coming out the tailpipe as well. So it really defeats the pollution control system. And so they had to phase out the lead in the gasoline. And then those cars that ran on leaded gasoline were eventually phased out as well. The exceptions to this are general aviation aircraft, race cars, farm equipment, and some marine engines are still permitted to use a leaded fuel. So let's take a look at the dirty dozen Utah point sources for lead in emissions of tons per year. Well, the largest source of lead to the atmosphere in the state of Utah is the Kennecott Copper Corporation, a smelter and refinery located just at the northern part of the Ochre Mountains here in the Salt Lake Valley. And they put out more than 3 tons of lead per year. You'll notice that number 2, 3, 4, 5, 6, and 7 are all airports: Provo Municipal, Ogden Hinckley, Salt Lake International, etc. And then we have a couple of industrial plants further on down. The ones that are shown with the star are ones that are actually located within the Salt Lake Valley. So we do have some significant contributors to lead within our own valley. And here we have the National Ambient Air Quality Standards for nitrogen oxides. So this is NOx, and the primary standards for the 1 hour average is 100 parts per billion, and then there's also an annual average, which is 53 parts per billion. And there are no areas in the country that are currently designated as non-attainment for NOx, and there's only one maintenance area, and that happens to be Los Angeles. If we look at the nitrogen oxide trends, back in 1980, we were already in compliance with the national standard, and that was true in Utah starting in the mid-1990s as well. And the concentrations have gone down slightly over that time period as the older cars that didn't have the catalytic converters were gradually replaced with newer models that had better pollution control equipment on them. So as I just stated, the NOx concentrations are decreasing because of technological advancement. And then we also have added scrubbing technology to many point sources. This is primarily from coal-fired power plants. There are some of those that have been scrubbed for nitrogen oxides. We also have increased fuel economy as well. The dirty dozen point sources for nitrogen oxides. Well, you'll notice that the first 3 are coal-fired power plants. The Intermountain Generation Station, which is the biggest coal-fired power plant in the state of Utah. And then we have 2 additional coal-fired power plants. And then we have the Kennecott Utah Copper Corporation concentrator, which is different from the smelter. And then we have another power plant. And then we have another power plant from Kennecott Copper, which has now been phased out. And then we have Cement Company and the Salt Lake International Airport because airplanes are not scrubbed for nitrogen oxides. The ones that are shown in red are the ones that are located within our valley. So you see that most of the coal-fired power plants are not located in Salt Lake Valley, even though they're putting out tens of thousands of tons of nitrogen oxide emissions per year. And most of that is not done locally. Let's take a look at the National Ambient Air Quality Standards for PM10. The 24-hour standard is 150 micrograms per cubic meter. And the areas that are designated as non-attainment for PM10 are all in the western part of the United States. Southern California, Southern Arizona, part of central, the valley in Willamette Valley in Oregon, and then the Salt Lake Provo municipal area, and then a couple of places up in Montana that are associated with industrial activity. So here we are in non-attainment for PM10 for Salt Lake and Utah counties. And that redesignation is pending. It actually just recently happened. The redesignation was done in 2020. And so Salt Lake and Utah counties are now considered to be in attainment, but they're a maintenance area. So PM10 trends. So the national trend is down slightly over the 30-year period from 1990 through 2009, but and we also see a little bit of that here in Salt Lake City as well. We had a big decrease from the concentrations in the early 1990s, and then it's just been a very slow, very gradual decrease over time. So why are the PM10 concentrations decreasing? Well, they had a state implementation plan in 1991 that was trying to decrease the PM10 concentrations, and they added control measures to some of the industries in our valley, including the smelters, the refineries, and the power plants. They switched from coal combustion in the winter to natural gas for some of the power plants that were still located within our valley. And in 1991, they created a wood burning restriction program for the first time. And then they also made some improvements to the vehicle emission inspection and maintenance program. So let's take a look at some of the highest PM10 concentrations for different sites here in Utah. So you'll see that we had those high concentrations in the early 1990s. The state implementation plan made some improvements, and starting from about 1996 moving forward, we were generally in compliance, and then it started to creep up again in the late 2007 to 2009 region, and then it kept creeping up, and then there was a new state implementation plan that made additional things to try and reduce the PM10 concentrations, and those have had a positive impact as well. So what are the dirty dozen Utah point sources for PM10 in tons per year? Well, the Kennecott Copper Corporation concentrator is the largest one, point source in the valley. And then we had power plants. We had the ATK launch system, which is the rocket building place up in Promontory. We have some more power plants. We have US Magnesium, which extracts magnesium metal from the Great Salt Lake. And then we have the smelter and refinery down at the bottom, which is also a big source of PM10. But these are point sources. There are also area sources, which are not coming out of a pipe or a smokestack, so to speak, which are significant as well. Let's take a look at the National Ambient Air Quality Standard for particulate matter, PM2.5. So the 24-hour average was 65, the standard was 65 micrograms per cubic meter from 1997 to 2005. And then that was revised based upon new science in 2006 to be 35 micrograms per cubic meter. And then we also have an annually averaged concentration of 15 micrograms per cubic meter for chronic impacts. So the counties that are designated as non-attainment for PM 2.5 are basically the St. Louis metro area, most of the Central Valley of California, most of the Los Angeles region, most of the San Francisco Bay Area, and most of the Wasatch Front, and Phoenix. There's also a couple of places in Pennsylvania and Cleveland that are also in non-attainment as of 2017. So for fine particulate matter, these counties all along the Wasatch Front were in non-attainment, and this is primarily driven by the fact that we have particle pollution in the wintertime during the cold pools or the inversions. We have very high concentrations of particulate matter, and most of that particulate matter, the bulk of it is actually nitrogen species. So it's ammonium nitrate is the most common species during our wintertime inversions. And that, of course, comes from transportation sources, which are a larger source of nitrogen oxides to the environment. If we look at our PM 2.5 trends, starting back in 2000, this is for the annual average, looks like. Yeah, so for the annual average, we are just, running between 10 and 15 micrograms per cubic meter, which is below the national standard, but not by a lot. And in the United States, most of the places are now below the national standard for the annual average for PM 2.5. But as population increases, there's always pressures on the PM 2.5 concentrations. If we take a look at some real data from different sites here in Utah, we had the old standard of 65 that was in place back in the early 2000s, and the concentrations at all of the sites along the Wasatch Front here were below the old standard of 65. But in 2006, the standard was lowered to 35 micrograms per cubic meter, and instantly Utah became out of compliance. It wasn't that our concentrations had changed, it's that our understanding of the health impacts of the particulate matter had changed, and the standards were revised downward.